Hi everyone, my name is Vitalii. I am senior iOS engineer at Sally, and I know what some of you are thinking right now. Why is an iOS engineer up here talking about Android? So over past few weeks, I've been writing production Android code on our actual app, and I want to tell you how that went. From a perspective, I think both sides of this room will find interesting. So here is how this started. Our head of engineering had an idea, and he suggested an experiment. Take me, someone with zero Android experience, and give me real production tasks on Android app. Not a tutorial, not a side project, just actual tickets that needed to ship. The catch, I would work entirely with AI. And the question we wanted to answer wasn't like, can AI write Android code? We already knew it could. The real question was, can a senior engineer from a completely different platform use AI to ship production quality code? And what does that tell us about how engineering roles are changing for all of us, iOS and Android alike? And this is basically on the picture. This is basically me when I first opened the Android Studio after Xcode. Yeah, and I think that this question matters for everyone in this room because most engineering teams are split by platform. We have like Android team, we have iOS, backend, frontend, and there are good reasons for that because like deep platform knowledge take years to build. But what if that boundary is softer that we all assumed? And what if the hard part was never the platform-specific syntax, but the engineering judgment underneath it? And that's what I want to explore with you today. And I want to be upfront. This is not a sales pitch for the AI. I'm going to show you where it genuinely worked, where it gave me false confidence, and where I think this is all hidden. So before I wrote a single line of code, I did the most important thing. I defined a set of project level rules, not just style guidelines, but concrete examples of how to write code in our code base, rules for architecture, rules for how view models should be structured, and rules for how to write tests. And crucially, these rules were included with actual code examples. And we actually built this at Sally into a system we call AI Toolkit. This is like a package that distributes skills, review agents, and quality hooks across all of our platforms. But the concept is simple. Codify your team's knowledge into something AI can follow. So why does this matter? Because when you give AI access to your repo, plus well-written rules with examples, the output stops looking as AI slop or like generic Stack Overflow code, and it starts looking like your team wrote it actually. So I think of these rules as a taste layer. They encode your team's standards in a way that AI can follow. And here is the thing. Whether your team writes Kotlin or Swift, this applies equally. These rules make onboarding faster, code review easier, and quality more consistent for every engineer on the team. And if you want to take a one actionable thing from this talk, invest in writing rules with examples for your project. So what did the actual workflow look like? Every task started the same way. I would open Claude in planning mode, of course, and describe what I needed to build. Not just like write me this code, more like here is the feature, here is the output that I would expect, here is what needs to happen, propose an approach. Claude would come back with the plan, which files to create, how to structure the use cases, what the view model should look like, and how the UI should be composed. Does this architecture make sense? Are we following the project patterns? Is anything missing? Only after I approved the plan would we move to the implementation. File by file, reviewing as we go, of course. So it's kind of like a conversation, not generate code and hope for the best. And because Claude had access to the full repo and it could see how the team already does things and follow those patterns. And that's made a huge difference, actually. So now, what did I actually build? Because I think the credibility of this whole talk depends on whether the work was real. So here are some of the PRs that got merged into production. First one is a complete async deletion flow. This is a full feature with API integration, with the new endpoint, use case layer, view model logic, and also I added animated UI with content transitions in the bottom sheet. So it's like a full vertical slice from network to pixels built in one planning session. Second, it's a new reward type. When users delete an async with an inactive plans, they can claim credits. This meant adding a new reward source that flows through the existing claim screen with the right labels and images. End-to-end feature. Third, it's a bit smaller one, but real. It's adding a copy ICC ID option to a menu, UI, view model, handler, and unit tests, of course. And on top of that, composable refactoring, animated transitions, making previews more interactive, and of course, writing unit tests. So, what surprised me? Actually, honestly, like how much felt familiar. Kotlin and Swift are remarkably very similar languages. The syntax, the type system, the way you think about optionals and pattern matching, I felt at home almost immediately. Data classes and sealed classes were new concepts by name. Regarding Compose and SwiftUI, same mental model, actually declarative state-driven UI. The component thinking is identical. Small views, each responsible for one thing composed together. And at the architecture level, MVVM use cases, repositories, dependency injection is the same everywhere. The design patterns don't care what platform you are on. And the biggest realization was this, that good code looks the same in every language, actually. So small focused components, clear separation of concerns, testable logic. If you know what good looks like, you know it on any platform, actually. Yeah, but not everything transferred smoothly, and I want to be honest about this one. So, flow collection patterns and lifecycle awareness. That's where I leaned on AI most. In Swift, we use structured concurrency with async await and combined for reactive programming. Kotlin has coroutines and flows. And while the concepts are like related, but the way you collect flows, scope them to lifecycle, cancel them, that's generally different. I couldn't have navigated that on just like instinct alone. And every platform has things the other side does better. For me, coming from iOS, SwiftUI previews feel more like fluid. They live in interactive, they are live and interactive by default. In Compose, you have to explicitly start the interactive mode. It's a small thing, but when you're like working on animations, that friction adds up. But it goes both ways. Android Studio's built-in tooling is incredible. I really was amazed comparing to Xcode. Like the network monitor, the database inspector, the layout inspector in iOS. You either need like some third-party tools for this, or you're working with much more limited versions in Xcode. And Google's developer documentation is excellent. It has clear explanations, good code examples, consistently up to date. The iOS folks, I guess, know how poor is Apple Docs, especially about like some advanced things. So the honest summary here would be that both platforms have things to be proud of, but both have things to learn from each other. And yeah, and Gradle, I just let AI handle Gradle on Android side. It's too much. So, all right. Now I want to tell you about like the most interesting thing that happened during this experiment. And this is not a feature, it's a bug. Let me just switch back and see. So you can see this weird shuffling animation. So we have a screen with the banners, and users were seeing something weird. Every time they left the screen and came back, the banners would shuffle and they see this weird, ugly animation. So annoying for them, and great for great debugging challenge for me. So I sat down with Claude and said, let's figure this out, my dear friend. So Claude's first diagnosis was confident, and it made sense actually. The lazy row doesn't have a stable keys, and compose can't track item identity, so it renders them in whatever order it gets them. And your sorting isn't fully deterministic, because when two banners have the same priority, the order is just random. And I thought, yes, that sounds exactly right. I've seen this exact problem in SwiftUI. We have the same concept in SwiftUI of identity. So yeah, I thought, okay, classic. So we fixed it, added stable keys, made a sorting deterministic, fully deterministic. I even built like an isolated interactive preview where I could shuffle the banners randomly to verify. And in preview, it worked perfectly. No shuffling, fixed. I submitted the fix, but bug was still there, and banners were still shuffling on the real screen. Second round. So I went back to Claude and said, look, this is not the UI related issue, but it's something that relates to the how data flows. Let's take a look into the view model and how data is flows. And that's when we found actually the real issue. Actually, multiple issues chained together. So first, there was a nested flow collection in the view model. So a collect call sitting inside a collect latest on the refresh state. So what this meant was every single time the user re-entered the screen, the flow collection restarted and fresh emission was emitted every time. But it got worse, because when the refresh kicked off, the state transitioned to in progress, and during in progress, the unclaimed credit amount was set to 0. And 0 meant that claim credits banner got filtered out, so it didn't qualify anymore. Then, when refresh completed successfully, the amount came back, so the banner was qualified again, and it was re-added to the list. So this is actually what users observed as the banner disappearing and reappearing with animation. So 3 issues layered on top of each other. So the actual fix touched 4 things. First, we added distinct until changed on the message repository to prevent duplicate emissions. Then we separated the in-app message observation from the refresh state using flatmap latest. Also, we added a helper for like to preserve object references, as compose wouldn't recompose when banners were like fully equivalent. So AI's first answer is almost always the most obvious answer, the textbook one, and often the obvious answer is like it's partially right, which is actually more dangerous than being completely wrong, because you implement it, it sort of makes sense, kind of works, and you're like moving on. So the senior engineer's job here, like on any platform with any AI tool, whether you're using Cursor, Claude, or Codex, whatever, is knowing when to say this isn't enough. Let's dig deeper. And that's not a skill AI gave me. That's a skill I brought from years of iOS development, and it transferred just perfectly in this scenario. So let me try to be precise about where AI actually helped and where it didn't. So it was excellent at syntax translation. I am thinking in Swift, Claude writes Kotlin. The gap between what I meant and what ended up in the code base was surprisingly small. It was excellent at following established patterns, but only because we had rules with code examples. Without those, the output would be just generic. With them, it matched our code base style. It was great at scaffolding, setting up a use case, wire up view model, creating test boilerplate. So these like mechanical parts of engineering that take time but don't require deep judgment. Where it struggled. You just heard the backstory. So multi-layer debugging, where the real cause is 2 or 3 abstractions deeper than the symptoms. So it kept wanting to fix what it could just see. So I had to push it to look at what it couldn't. So the shift is happening, yeah, and this is like from Greg Brockman. He is a co-founder of OpenAI. I think he is right. I would just add something here. So the renaissance isn't just about the speed only, it's about who can do what. 6 months ago, I would never written a line of Kotlin, and here we are. So what does this mean for all of us, for how we work? I think writing code by hand, like the act of typing the syntax, is no longer the core skill of software engineer. I know that's a bold statement, but I just shipped like production Android features in a language I had never written before. The syntax wasn't the bottleneck, not even close. What mattered was everything like around the code, writing clear specs, thinking about architecture, design system design, reviewing output for quality, catching edge cases, and understanding why something works, not just that it works. So the development process is becoming more like a conversation between engineer and AI. But, and this is very, very important, the engineer still needs to understand the code. You still need to understand the patterns, the life cycle, the platform nuances. So AI doesn't replace your judgment, it just amplifies it. For teams, I think a few things follow from this. First, cross-platform code reviews become realistic. If an iOS engineer can read and understand Android code well enough to ship it, they certainly can review it. Second, I think the role of platform engineer might gradually evolve into product engineer, someone who can work across the stack guided by AI and anchored by engineering judgment. And I think everyone in this room, whether you write Kotlin or Swift today, should be thinking about that shift. And third, and this is the most practical thing I can tell you, invest in your project rules, write them down, include code examples, make them specific, because those rules aren't just documentation for humans anymore. They are like the interface between your team's standards and every AI tool your team will ever use. So the gap between platform is shrinking very fast. AI is closing it really fast, but the gap between good and bad engineering judgment, that's not going anywhere. And yeah, AI didn't make me an Android developer. It just it just made my engineering judgment portable. Thank you. I'm happy to take questions.
If you have any questions.
Hello.
Hey.
Thank you.
Hey.
Thank you for the presentation. Question. Did you iterate over the rules that you provided to the cloud?
Sorry, did you what?
Iterate on the set of rules that you provided?
Yes, of course. It's like always on process, you know, you just iterate.
Yeah,
So
but for example, with this bug, how did it go?
Yeah, so 2 rounds. But you mean, did I iterate over the rules?
Yeah.
No, over the rules, no. I just was iterating like by the first version of the plan that it gave me, like with the lazy row stable case. And then like the second round was like, okay, we have to go to the view model, you know, itself.
Okay. One small question.
Yeah,
but
sure.
was it like one chat with Claude or multiple chats?
It's multiple. It was multiple in.
And did you
chats.
reuse the context?
No, you can give him like actually you can give him a context, but for example, if you will clear the first chat for the UI bug, let's name it, you can, for example, you just clear, then start a new session, and you can give me, hey, we fixed this, we added this, this like helped, but it's still not the root cause. It will understand much more.
Oh, okay.
Yeah.
All right, I'm sure you can catch each other during the break and ask more questions. One more question. You, right?
Yeah.
Hello.
Hi.
What do you think about using multiply AIs for example, checking each other?
I think it's a good thing because we had like AI review on our pull requests, and sometimes, you know, you can just review this, like the output of AI review, if it makes sense. But I think it's a good idea. Yeah. Thank you. I can switch it up, yeah.